welcome to our live classes. So I discussed freely falling body. We discussed in last class. So we have the conditions for freely falling body: u equal to 0, then a equal to plus c. These two conditions we have for freely falling body. So in freely falling body under gravity. Okay. Freely falling body under gravity. This is our last class topic. So here we have the conditions only u equal to 0. Acceleration we have to take positive. So this is a earth. This is the body. It is falling onto the ground. Falling onto the ground. So when freely falling, that is equal to u equal to 0. So the body due to earth, the earth is acting force, gravitational force on this body. So the body is accelerating. So body is getting acceleration. That is equal to plus. Here we have to take acceleration is equal to plus z. So these are the conditions. So for this one, before touching the ground, what is the velocity already we calculated? That is equal to 2gh. So u equal to 0 it started and reached velocity under root of 2gh. Velocity, the final velocity of the freely falling body before reaching the ground. Time equal to, already we calculated this one, 2h by g. So here, so for freely falling body, the time taken to reach the ground is 2h by g. Second, final velocity before reaching the ground is 2gh. Third case, average velocity of the body. So average velocity, already we have the formula, total displacement by total time. So it covered before touching the ground, that is h by total time taken, t. Simple, h equal to h by t, 2h by g. So root 2h, root 2 into root 2h, root g. So g by t under root. This is the average velocity of that body. So simply average velocity here, total time, how much total distance covered by that body before reaching the ground, and total time taken. So h by t, just substitute 2h by g, you will get average velocity. So one more, the body is here, u equal to 0, it is moving down to the ground. So here final velocity equal to 2gh. Final velocity equal to 2gh. So in last class we calculated, for example, this body covered this displacement in time t. So last class we calculated in first second displacement, second displacement, third second displacement, like that we calculated displacements s1, s2, s3. We calculate the ratio also. S1 is S2 is S3 equal to 1 is to 3 is to 5. 1 is to 3 is to 5. Now today we have to calculate. We are going to calculate first 1 second, first 2 seconds, first 3 seconds, first 4 seconds. So like that we calculate today. So this you write this one, S1 is to S2 is to S3, 1 is to 3 is to 5. That is first second displacement ratio with second displacement ratio with third second displacement, that is equal 1 is to 3 is to 5. Now this is a freely falling body. Conditions are u equal to 0, a equal to plus g, a equal to plus g is coming to the ground. So here h, for example, t equal to 1 second. In t equal to 1 second, how much displacement covered by that freely falling body? So s equal to ut plus half at square. Already we have the conditions for freely falling body, u equal 0, a equal to plus g. So here this term will goes to 0 plus half gt square. So half gt square in 1 second. In 1 second, not first second. In 1 second. Next, t equal to 2 seconds. S equal to ut plus half at square. U equal to 0, this term will goes to 0, half a equal plus z gt square, t equal to, so in 1 second means just you substitute here 1 equal to, just what we will get, g by 2 only, which is in 1 second. Substitute that time. Here also t square, g into 2 square. So you will get for 2g in 2 seconds. 2g in 2 seconds, g by 2 in 1 second. Like that, for t equal to 3 seconds, t equal to 3 seconds, s equal to half gt square, g into 3 square, 9 g by 2 in 3 seconds. See, we calculated here. What we calculated here? We calculated the body is falling freely under the gravity. So the conditions for this one, u equal to 0, a equal to plus g. So in t equal to 1 second, it covered displacement g by 2. In t equal to 2 seconds, the covered displacement 2g. In 3 seconds, 9g by 2. 9g by 2. Is there any relation? So just we conclude it. Is there any relation? S in 1 second is S in 2 seconds, S in 3 seconds equal to g by 2 east 2g east 9g by 2. So multiply with, so I think it is not visible. I am checking. I am doing here. See, 1 second displacement in 2 seconds, displacement in 3 seconds. So if you multiply with 2, you will get g east 4g east 9g. So displacement in 1 second, displacement in 2 seconds, displacement in 3 seconds equal to 1 is to 4 is to 9. That is equal to 2 square s in 1, displacement in 1 second, displacement in 2 seconds, displacement in 3 seconds. So like this we get. In particular, 1 second, 2 seconds, in 3 seconds, you will get like this. In first second, in second second, that is equal to 1 is to 3 is to 5. Just copy it. After copying, message me yes or no. Just copy it. So here what we did here, simple. In last class we discussed in first second displacement, in second displacement, in third second displacement. We got that value is 1 is to 3 is to 5. 1 is to 3 is to 5. Here what we are doing, in first second, 2 seconds, first 2 seconds, comma first 3 seconds, first 1 second, first 2 seconds, first 3 seconds, t equal to 1, t equal to 2, t equal to 3. Then we are getting 1 is to 2 square is to 3 square. So this is the displacement acquired by the body, acquired by the freely falling body in first 1 second, in first 2 seconds, in first 3 seconds. The values are in the ratio 1 is to 2 square is to 3 square. Here in last class 1 is to 3 is to 5. In first second displacement, second displacement, third second displacement. That is difference. Have you got the difference? Is it okay? Did you get the difference? What is the difference in last class to this class? 1 is to 3 is to 5, 1 square is to 2 square is to 3 square. What is the difference? What is 1 is to 3 is to 5? 1 is to 3 is to 5 ratio is for in first second displacement to second displacement, in third second displacement. 1 square is to 2 square is to 3 square is nothing but in while falling the freely falling body, it cover displacement in first 1 second is to first 2 seconds is to first 3 seconds. That is the value is equal to, the ratio is equal to 1 is 2 square is 3 square. Okay. Just copy it. Then one more. One more case, ratio of travel in first 1 meter, first 2 meter, 3 meter. Ratio of travel, write this. Ratio of travel in 1 meter, 2 meter, 3 meter, times taken ratio. That means this is a freely falling body, u equal to 0. The condition for freely falling body, a equal to plus z, is falling down to this earth. So first 1 meter, how much time taken? First 2 meters, how much time taken? First 3 meters, how much time taken? For covering first 1 meter, how much time taken, covering first 2 meters, how much time taken, first 3 meters, how much time taken. So for this one, the ratio travel in 1 meter, 3 meter times taken. See here, what we have to find, ratio of traveling time in first 1 meter, 2 meter, 3 meters. So T1 is nothing but here to travel 1 meter distance from top, from top. T2 to travel 2 meter from top. T3 to travel 3 meter from top. So to travel 1 meter from top, that means time taken for 1 meter, time taken to travel for 2 meter, time taken to travel 3 meter. So I am using, we have kinematic equations here. What are kinematic equations? We have 4, that is equal to V equal to U plus AT, S equal to UT plus of AT square. So from this, S equal to 1 meter, U equal to Z plus Z, A equal to U equal to 0, A equal to plus. These are the freely falling body conditions. So I am trying to build a ratio. I am trying to calculate a ratio between the time taken by the body to travel 1 meter to the time taken by the body to travel 2 meter to the time taken body to travel 3 meter. That is equal to first one, S equal to 1 meter, U equal 0, A equal plus Z. 1, UT is 0 of GT square. Here T1. So I'll get what we will get, T1 square equal to 2 by G. Is it? Then T1 equal to under root of 2 by G. First one. Next, S equal to 2 meter, displacement covered by the freely falling body. The conditions are U equal 0, A equal to plus G. So 2 UT, this will goes to 0, so of A equal to G, T square, T2 square. So T2 equal to 4 by G under root. 4 by G under root time. So for S equal to 3 meter, U equal 0, A equal to plus 3 meter of G, T3 square. T3 equal to 6 by 9, 6 by G under root. So what are the ratio here? We want to calculate ratio. Time taken to travel 1 meter, time taken to travel 2 meter, time taken to travel 3 meters from freely falling position. So root 2 by root G east, root 4 by root G east, root 6 by root G east. So you just cancel it, these things. So T1 east, T2 east, T3 equal to root 2 east, root 4 east, root 6, like this. This is the relation we got from first 1 meter, the time taken by the body to cover first 1 meter, the time taken by the body to cover first 2 meter, the time taken by the body to cover first 3 meters. Root 2 east, root 4 east, root 6. You just copy this one. This one more relation. Time taken, ratio of traveling time taken to reach 1 meter, 2 meter, 3 meter. Okay, so I'm going to finish this topic, freely falling body. So you have to remember simple, the conditions are two only: u equal 0, a equal to plus c. U equal 0, a equal to plus c. One more, body second. First one we finished, freely falling. So it's not visible, I think. Yeah, it is visible. Freely falling body. Freely falling body. Second, body projected, body projected vertically up, vertically up. So this case, u equal to 0, a equal to plus z over body projected vertically up. That means take a ball and project up, project perpendicularly. See, projected up. Just if you take a body and project up. So what are the conditions for project up, vertically upward, not project obliquely, just projected vertically up? That means it will go straight. If you project it, it will go straight only, top, vertically up. Vertically means pike, upside only. Okay, for these conditions, so here for this one, this is the body, it is moving up, 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 vertically projected. So at maximum height, the body velocity equal to 0. Final velocity body is equal to 0. So acceleration. So it is, this is the earth. It is moving opposite, vertically up, vertically up. See, generally the gravitational force acting on this body downward. Gravitational force acting mg, that is weight, the weight of the body acting in downward side, gravitational force acting downward side, but we are projecting this body in vertically up position, vertically up position. So it max, to reach at maximum height, to reach to maximum height, at maximum height, the final velocity of the body is 0, but initial velocity is not equal to 0. So we have to project with some velocity. We have to project the body with some velocity. Then only it will go up. Then only it will go up. So the weight is directing downward side. The body is moving upward. So the acceleration take. So generally the force acting downward side, the body is moving upward side. Are you getting my point? When you projecting up the ball, ball పైకి విసిరేసినప్పుడు ఏమవుతుంది, పైకి వెళ్తుంది. But gravitational force act on that ball is downward side. The acceleration direction is, body is moving upward, acceleration, gravitational acceleration acting downward. So take a equal to minus c here. This is a second condition for a body projected vertically up. These are the easy, but if you catch the point, it is easy, otherwise it is difficult. See, what I am saying is, I am repeating this one. See, I am comparing freely falling body, u equal to 0, just we open our fingers, the body will goes down. This is freely falling body. So that means we are not giving any velocity to that ball. Initial starting లో మనం బాల్ వెలాసిటీ ఏమి ఇస్తున్నాం, జస్ట్ మనం ఫ్రీగా వదిలేస్తుంది. That is freely falling body. Those conditions are u equal to 0, then the ball is going down to the earth. The ball is going, the body means here we are taking ball, the ball is going down to the earth. So why it is going? The gravitational force acting on the ball is going down. So force acting in that direction only. The displacement of the body also same direction. So what is happening here? This is the earth. So the body is moving downward. Gravitational force acting in this body also downward. So that is A equal to, we are taking, both are in the same direction. Both are in the acceleration, the force downward side, the body is moving also downward side. Accelerating downward only, the force acting also downward. So the body is going down, that means the force acting on that body towards the earth. The body is also accelerating towards the earth, accelerating towards the earth, force acting towards the earth. So both are in the same direction. So A equal to plus C. But here in the second case, so this is a wall, we are projecting vertically up, so it will move like this. It will move after going maximum height, after reaching maximum height, the velocity of the body will be 0. This is final velocity of the body is 0. Final velocity of the body is 0. So the body is, we are projecting with some velocity, with then only the body will go up. If you are not giving any velocity, ఏం స్పీడ్ లేక ఊరికనే పైకి వదిలేస్తే బైక్ పోదు. So we have to give some velocity, then it will go up. At reaching maximum height, the final velocity of the body is 0. So here initial velocity not 0. Then the body is accelerating in this direction, force acting, the gravitational force acting downward side. So have you understand this one? The body is accelerating, it is getting velocity, there is change in velocity in the upward direction, accelerating in the upward direction, but gravitational force acting downward side. So A equal to, here you take opposite direction, that why A equal to minus Z. These are the conditions for body projected vertically up. You simply remember, here the body is accelerating downward side, gravitation force acting in the body also downward, both are in the same direction. A equal to plus C. Accelerating of the body, acceleration of the body, that is equal to gravitational acceleration. Here the body is moving up, gravitational force acting downward side. So both are in the opposite direction, both are in opposite. A equal to minus C. At maximum height, V equal to 0, not U equal to 0. Here V equal to 0, here U not equal to 0. These are the projected vertically up conditions. So you just don't write already, you write this one. This case also you written, only you write this case. What you are write conditions. At max height, its maximum height, V equal to 0, one condition, 1, A equal to minus G. This is the, at maximum height, velocity equal to 0, this is one condition, acceleration equal to minus G is the second condition. Why it is minus? The body is accelerating upward side, the force acting downward side, both are in the same direction. So gravitational acceleration downward side, the really the body originally it is accelerating is linearly, that is A equal to minus opposite. Okay, if you copy it, just copy the figure. I will give some discussion here. Okay, next I am giving one more. Vertically projected, body projected vertically up. So here, this is the body, it is going perpendicularly up. Okay, here at maximum height will be equal to 0. This is the maximum height, h max, which is h max. At maximum height, final velocity is equal to 0, a equal to minus. So it is going up, then the final velocity is 0. Then what happens? The body will fall to the ground. Nothing is there. Simply it is going with some velocity, going up. At maximum height it reaches, then the final velocity will be 0, then will fall to the ground. So when the body is reaching to maximum height, that is time of ascent, time of ascent, ascending, time of the body is ascending, that is means time of ascent. So time of ascent is equal to time, write this, time taken to reach maximum height, time taken to reach maximum height. The body is reaching maximum height. How much time taken? That is time of ascent, time of ascent, time of ascent. You just write this one, time of ascent, time taken to reach maximum height. Next, after reaching maximum height, the final velocity is 0, then we fall to the ground. It comes back to the ground. So here, what is happening here? Time of descent. This will is time of ascent, TA. This will time of descent. The ball is the time taken by the body to reach the ground. So here on this one also you just write time of descent, time taken to reach the ground from maximum height. Is the maximum height. So what we are saying? We are taking two here. Time of ascent, time of descent. The body is getting maximum height. How much time taken to reach maximum height? That is time of ascent. The body is reaching to the ground from maximum height. How much time taken to reach the ground from maximum height? That is time of descent. So two words I introduced to you: time of ascent, time of descent. So just this one. So here time of ascent, time of descent. So this is the time taken to reach maximum height. This will become time taken to reach ground. Time taken to reach maximum height, time taken to reach ground, reach to the ground. Time of ascent, time of descent. So my question is TA and TD are equal? My question is T and TD are equal or not? Okay, is these are equal? Time of ascent is equal to time of descent? Yes, time of ascent equal to time of descent. That means మనం ఒక బాల్ని పైకి మ్యాక్సిమం హైట్ రీచ్ అయ్యే వరకు వెళ్ళేసిన తర్వాత మ్యాక్సిమం హైట్లో ద వెలాసిటీ ఆఫ్ ద బాల్ విల్ బి 0. అప్పుడు 0 అయిపోయిన గెట్ ఫాల్ స్లోగా డౌన్ ఫాల్ అండ్ గ్రౌండ్ కమ్స్ టు ఎర్త్. ఎంత టైం తీసుకుంది మ్యాక్సిమం హైట్ రీచ్ కావడానికి? టైమ్ ఆఫ్ అసెంట్. ఎంత టైం తీసుకుంది మ్యాక్సిమం హైట్ రీచ్ గ్రౌండ్ రీచ్ కావడానికి? బోత్ ఆర్ ఈక్వల్. వెన్ time of ascent equal to time of descent, when the body is in vacuum. వ్యాక్యూమ్లో ఉండాలి బాడీ ఉండాలి. వ్యాక్యూమ్ అంటే అక్కడ ఏముండదు, గాలి ఉండదు, ఏముండదు. నథింగ్ ఈజ్ దట్. దెర్ ఈస్ నో నథింగ్. ఓన్లీ ఎయిర్ రెసిస్టెన్స్. గాలి ఉంటే రేర్ రెసిస్టెన్స్. గాలి ఏం చేస్తుంది, గాలి అటు ఇటు జరుగుతుంటుంది బాడీ. సో ఎయిర్ రెసిస్టెన్స్ షుడ్ బి జీరో. వ్యాక్యూమ్లో అయినా కావచ్చు, లేకుంటే ఎయిర్ రెసిస్టెన్స్ జీరో ఉన్నప్పుడు మాత్రమే టైమ్ ఆఫ్ అసెంట్ ఈక్వల్ టు టైమ్ ఆఫ్ డిసెంట్. ఈజ్ ఇట్ ఓకే ఫర్ యూ? హ్యావ్ యూ అండర్స్టాండ్? If you understand time of ascent equal to time of descent, what is time of ascent? Ascending, it is going up. Descending, it is going to down to there, it is going to maximum height. Time of ascent equal to time of descent. Both are equal when the body is in vacuum. Vacuum లో ఉన్నప్పుడు both are equal. అలా కాకుండా ఎయిర్ రెసిస్టెన్స్ అనేది ఉండదు. ఎయిర్ రెసిస్టెన్స్ ఎలాంటి డిస్టర్బెన్స్ ఉండదు. దెన్ ఓన్లీ TA equal to TD. Okay. See, body projected vertically up. We have the conditions here. V equal to 0 at maximum height, final velocity equal to A equal to minus Z. Then time of ascent equal to time of descent. These are the conditions. Okay. Just copy it. See, in this case we are checking maximum height. దీంట్లో maximum height. So H max. So here this suffix denotes maximum height. H max. So the body U equal to not equal to 0. We are giving some velocity to body to reach maximum height. So we are projecting. It is going up. It is going maximum height. Here final velocity of the body will be 0. You just observe clearly. The body starts with some velocity. We are projecting up. It is going to maximum height. When reached maximum height, the final velocity of the body is equal to 0. Here initial velocity is not equal to 0 in this case. Okay. So how much maximum height reached by the body? That is our question. So we have formula S equal to UT plus half AT square. S equal to UT plus half AT square. Then V square minus U square equal to 2AS. In these two equations we have displacement term. So which is suitable? Is this suitable? Is this equation is suitable for finding H maximum? Just you message me 1 or 2. I am giving this is third equation, this is fourth, this is second equation, kinematic equation, this is third. So 2 or 3, which is suitable to calculate here maximum height? 2 or 3, just message me 2 or 3. If it is 2 is correct, message me 2. If third is correct, message me 3. Is suitable అవుతుంది ఇక్కడ. Is there any time? Am I given any time? No. So first one is not suitable here to calculate maximum height. This third equation we can use for finding H maximum. Okay, good. Now so for this case V equal to 0, 0 square, u is not 0, u square, 2a, a equal to projectedly up, projected vertically up, a equal to minus z, s equal to h max, displacement covered by the body towards to reach maximum height, that is h max. Is it? Okay. Minus u square equal to minus 2g h max. So minus minus gets cancelled. You will get 2g h max equal to u square, h max equal to u square by 2g, u square by 2g. This you write it. So the body projected vertically up. So what is the maximum height to reach? The what is the body reach maximum height? For maximum height formula, h max equal to u square by 2g. You just write it. Okay. So in vertically projected up, that case a body is projected vertically up. What is the maximum height? Is equal to u square by 2g. You have to say this answer. Okay. Here in this, h max equal to u square by 2g. So here 2 is constant, g value also constant, 9.8 meter per second square. Already I given the value. These two are constant. So h max is proportional to u square. That means initial velocity of the body which is projecting vertically up, that the body is reaching maximum height depends on u square times. మనం బాగా స్పీడ్గా విసిరేసినాం అనుకో, బయటికి పై అప్ సైడ్ స్పీడ్గా విసిరేస్తే ఇట్ విల్ గో మ్యాక్సిమం హైట్. తక్కువ స్పీడ్తో ప్రొజెక్టింగ్ చేసాం అనుకో, పైకి విసిరేసాం అనుకో, తక్కువ హైట్ వెళ్తుంది. దట్ ఈస్ ద రిలేషన్, నథింగ్ ఈస్ దర్ హియర్. h max is proportional to u square. So for example we can write like this: h1 is h2 equal to u1 square is to u2 square. So leave this one, no problem. Just you write this one. H max is proportional to u square. For example, we are projecting a body with 10 meter per second. The body will reach some height. If we project with 20 meter per second, the body will reach. In second case, the body will. In the second case, will the body reach maximum height greater than in first case? Yes. For example, with 10 meter per second we are projecting, it will reach h1. If we are projecting with 20 meter per second, it will go h2. So h2 is greater than h1. తక్కువ స్పీడ్తో విసిరేస్తే తక్కువ దూరం వెళ్తుంది, ఎక్కువ స్పీడ్తో వెళ్తే ఎక్కువ హైట్ వెళ్ళిపోతుంది. దట్ ఈస్ ద రిలేషన్, నథింగ్ ఈస్ దర్. u is more, h max is more, u is less, h max is less. So this is one more relation. You just write, copy it. Okay, next, second. So this is the vertically projected diagram. Final velocity at maximum height v equals 0, a equal minus z, u not equal 0. This is h max. So here b case, time of ascent and time of descent, both are equal. When time of ascent equal to time of descent equal, if there is no air resistance, ఉండదు, the body is in vacuum లో ఉండాలి, then only time of ascent equal to time of descent. So what is the time of ascent? For calculate, we have to calculate time of ascent formula. So here u not equal to 0, v equal to 0 at maximum height, a equal to minus g. We have the formula v equal to u plus 8. V equal to u plus 8. Here v equal to 0, in this case u only, u not equal to 0, a equal to minus g, is it? So it is reaching maximum height, so put here time of ascent. Time of ascent, u equal to u minus g ta equal to u by z, ta equal to u by z, ta equal to u by z. U is initial velocity, g is gravitational acceleration. Time of ascent equal to u by z. Can you calculate time of descent? Just you calculate time of descent. You just copy and calculate for time of descent. Okay, now I will give 2 minutes to you. Okay, did you calculate time of descent, time of ascent? So I am calculating now time of descent. So this is time of descent. So for time of descent, the body is at maximum height v equal to 0, then comes down to the ground. So for this, when the body is coming from at maximum height, initial velocity of that body is equal to v equal to 0, that is equal to u equal to 0. At maximum height v equal to 0, for this motion, that is initial velocity, u equal to also 0. Then v equal to v not equal to 0. Okay, then a equal to minus z. Okay, v equal to u plus at. V not equal to 0. V means here u. V means u. Here u means initial velocity is 0. A equal to minus. This is Td. So Td equal to, so I am giving one more time, v equal to u plus at. It is moving, it is coming down. Initial velocity of that body is equal to 0 while it is coming back. Final velocity is equal to u. So this direction you take just minus u. Then a equal to, it is traveling down. Traveling down means a equal to plus z, gt, td. Td equal to u by z. Did you understand this one? Is there any confusion? Did you understand? So I will explain one more time. Time of descent. It is traveling with time. In the time of descent, descending path, initial velocity is 0. plus a equal to in this direction, a equal to plus z. So why? Because it is traveling downward side, the force acting also in the downward side. So a equal to plus z, td, v equal to u. Instead of as this one, it is going down. U. Then td equal to u by z. So what we understand now, TA equal to u by z, TD equal to u by z. So finally we can conclude TA equal to TD, time of ascent equal to time of descent when air resistance is 0. Air resistance is 0. We just copy it. Last one, if you copy it, message me complete. Message me text box completed. Then I will go last concept here. Here, what happens? It is going down, going up, time of ascent TA. It is coming down, time of descent TD. So it is going up and coming down. So this, it is reaching same position. So this is time of ascent plus time of descent. Total, see, total time of flight. Total time of flight. Going up, reach maximum and comes to down to the earth. So that is equal to total time of flight equal to TA plus TD. Already we got TA equal to u by g, TD is nothing but u by g. 2u by z. For this is total time of flight. 2u by g. Okay. You just read all the concepts today. I will explain tomorrow some note. Regarding to this topic, we will do some calculations. Okay. Thank you. Just copy it. Have you understand this topic? Is it okay for you? Message me it if it is good. Message me good. Is bad? Message me bad. Just message me first. Then leave. What happens? Okay, bye. Just copy it.